facing the Cayman Islands marine environment, and we've also heard about the successful implementation of marine protected areas in Cayman over the last 25 years. But to date, the Department of Environment has never really had a comprehensive review of those parks to see if they were performing as anticipated. This study represents some of the first scientific evidence that really shows some encouraging results. Marine protected areas around the Cayman Islands have worked. We've long suspected that was the case given the health of much of the areas of the environment, but it's nice to see it on paper, so to speak. So moving ahead, I'm going to take some time to walk through some of the results that we found to date as Croy McCoy has led this team around some of the 62 sites in the Cayman Islands. Using coral cover as an index for the health of the marine environment, simply a measurement of the amount of live tissue that you find on a reef environment, you can see that within marine protected areas, live coral is significantly higher than around areas outside of the marine parks, and this is to be expected. Living coral is the backbone to the reef environment, and when you remove stresses through marine protection, those corals respond accordingly. Similarly, as we've heard, there's a significant relationship between fish health and with better fish populations, so we find that the coral reefs themselves respond with higher amounts of living coral. Conversely, on the other end of the spectrum, we've heard of the damaging effects of macroalgae, and when you look within marine protected areas, sure enough we find less of damaging macroalgae than in areas outside of marine protected areas, and this again is probably to do with a very strong relationship with the fish that are extracted from systems when there is no protection. Unfortunately, the graphs for Cayman brack don't quite show the relationship that we were expecting, but this is a good indication that parks really need some very careful consideration when they're put in place to make sure they're the right size, they're in the right place, and that enforcement is a major concern. Just to give you an indication of what a reef might look like when systems aren't functioning as anticipated, the slide to the left shows the reefs in Georgetown in the 1970s. You'll note that coral cover in this slide is extremely high, diversity also very high, lots of branching corals, and more importantly not a lot of space on that reef for anything to settle. The bottom right shows a slide from around the 2000s, again in Cayman. You'll note that the scene is very different. Corals are a lot smaller, the diversity is lower, but in between the corals we find a lot of the fleshy macroalgae that we were talking about. The dead corals that are in the slide are also covered with algae. All of this creates a stressful environment and makes it difficult for corals to survive in that environment, and indeed for corals to recruit to that environment. I'll just walk you through a set of data that we have from the Grand Cayman long-term monitoring project that the department implemented in 1996-97. We've cemented at various occasions around the island pins into the reef which enable us to go back and repeatedly survey very accurately using photographic equipment the exact same area. The slide on the left shows a scene in 1997. By the time we got to 2007, the exact same area is still being represented in the picture, but you'll notice that the coral cover is considerably less. What did that look like as a time series? Well, in 1997 we can still see signs of coral stress. Decline in reefs had probably already started long before this slide was taken, but nonetheless there is considerable amount of coral cover in this picture. During 1998 we experienced considerable amounts of bleaching. This was a phenomenal event, the worst on record, and Cayman wasn't spared. You'll see the corals turned a ghostly shade of white. By 1999 they had recovered to some extent. You'll notice that already a lot of the coral is missing, but the top right hand coral had regained most of its colour back and the tissue was surviving. By 2000 we're starting to see the stress at that bleaching event with the live coral patches starting to diminish, and if we jump to 2007, again the exact same slide, we see that coral cover is significantly reduced. And this trend is happening throughout the Caribbean. If we take a quick look at the literature that's been produced on this, you'll see that in the 1970s, coral cover around the Caribbean from scientists that were studying it was being recorded at about 50 to 60%. This is phenomenally high amounts of coral. The graph through to the 2000s shows a very, very significant and catastrophic decline to about 10% of coral now being reported by study throughout the Caribbean. We've added the red dot to the slide because we think that gives us a little bit of optimism. That is indeed where Cayman's reefs currently fall. We're the right side of the slope, and we believe that is a direct result of management intervention in marine parks. Coral cover in the Cayman Islands is somewhere in the order of 20 to 25%. Coral bleaching and disease, we've heard, are elements of stress, and if we use that as an indices when we are surveying parks, we would imagine that in a marine protected area where stresses are reduced, we would expect to see a similar decline in the incidence of coral diseases and indeed bleaching. Sure enough, when we look at coral bleaching as an index and we look in Grand Cayman and Little Cayman and the BRAC, we find that coral bleaching incidence is indeed less in marine protected areas than outside. So we can surmise that perhaps the parks are affording protection, allowing the corals to resist, or if you like, be more resilient to the effects of bleaching. Outside of marine protected areas, the incidence of bleaching is higher. Coral disease, as we've heard, is also related to bleaching. When corals bleach, they're more susceptible to disease, but similarly they're also more susceptible to disease when algae and other elements are present in the system. If these areas are reduced within a marine protected area, we would like to see a corresponding decline in coral disease incidence, and sure enough, Grand Cayman and Little Cayman show that relationship. Unfortunately, Cayman BRAC does not support this, and we see that there are higher incidences of disease in the marine protected areas than outside, which is unfortunately the opposite of what we would expect. Coral recruitment is an important process on reefs. Reefs are living systems that require new individuals to be introduced to the system as corals die either through disease, stress, or just naturally. Coral requires a hard substrate with which to attach to, and if a reef is covered in algae, juvenile corals, which are free-swimming individuals, find it very difficult to attach to the surface if the surface is already occupied with algae. So, with the anticipated effects of marine protected areas being that algae is reduced, we would expect to see higher amounts of coral recruitment in marine protected areas. And sure enough, across the board, Grand Cayman, Little Cayman and the BRAC all show higher amounts of coral recruitment within a marine protected area. Recruitment is still occurring outside, but certainly it's encouraging to see that marine parks do indeed encourage coral recruitment or allow corals that have recruited to survive long enough to become part of the system. Reef fish is perhaps the most obvious parameter for marine protection. If you stop extractive use and remove fishing pressure, you would expect to see a corresponding increase in the amount of fish. We've surveyed around the 62 sites, and indeed Grand Cayman and Little Cayman show very strong relationships with increased protection leading to larger fish and more of them. We've heard about the importance of large fish, but obviously more fish is also an important element to marine protection. Cayman BRAC doesn't quite show such a neat relationship, but the north coast marine protected areas do indeed support a larger abundance of fish than outside of the protected areas. If you imagine that marine parks have larger amounts of fish and that in the natural environment there aren't any boundaries between the parks and outside, those fish therefore are free to swim from a marine protected area. And this is an important part of marine parks. We've heard the term spillover, and it literally involves fish moving from marine protected areas out into open areas where they can be legally fished. We've done some studies to see if this effect is measurable, and sure enough, when you look at the boundary of a marine park within 1 kilometre or half a mile, sure enough, we found a large amount of fish available for extraction. By the time you've moved 5 kilometres away, or 3 miles or so, we see that there is a significant decline in the number of fish, and it's a nice straight line relationship there. We repeated the study in 2011, and the graph to the right, although not so neat, still shows the same relationship, with significantly more fish being found within the first 3 kilometres or 2 miles from the edge of a marine park as the fish move out of the marine protected areas and become available for fishing. By the time you become 5 kilometres away, fishing is returned to background levels. So you could imagine a system of marine protected areas, if you like, if we were to have another system on the other side, so you would have the reverse relationship and the amount of fish would increase as you got towards the park. And this is perhaps one of the options that might be available. Fishing pressure is a new threat to the Cayman Islands. It's one that we've suspected would start to have quite a significant impact as the sciences of reef has moved on. We know now that fish perform a very important function on the marine system, and if you move those fish from the system in large numbers, they're not available to carry out the services that reefs require. Fishing pressure in Cayman has grown as population has grown and demographics have changed the traditional fishing practices, leading to a significant area of concern. The Department of Environment has conducted a significant amount of surveys, face-to-face interviews with fishermen and recreational individuals to find out some level of what that fishing pressure might be. The graphic here simply represents the areas that we've found that fishermen tended to frequent. The study, as I mentioned, was quite detailed, so we were able to determine where fishermen went, types of species that they're targeting, and the areas, why they go to the areas that they do. The important point from the survey was indeed the amount of fish that's being removed. 264 fishermen targeted some 15,000 fish. The startling fact was the percentage of those that were actually reef fish, the important fish that are needed on a reef to improve its resiliency. Sure enough, about 13,200 of those fish are reef fish, concentrating mainly in the snapper, the triggerfish and parrotfish. All of those species are vital to a healthy reef system. The amount of fish caught per person is about 72, which, if you can imagine, extrapolate that up to a much larger numbers of people that are going fishing in Cayman, then that number of 15,000 becomes even more significant. Cayman brack and Little Cayman were also repeated, and we see a similar relationship here, both in the amount of fish being caught, 78 fish caught per person. Extrapolate that out, again, is a significant amount, and also in Little Cayman, where we see on average about 56 fish are caught. One of the important aspects of this, or an area that we think is encouraging, is the proportion that groupers make up of the catch in Little Cayman. We see a significantly higher amount of groupers being caught in Little Cayman, and we think that's a direct relationship from the fact that there is a very healthy spawning grouper population in Little Cayman, which has remained under protection for the last 8 or so years, and we're starting now to pick up increased amounts of grouper within the surveys that are being conducted, and also in fishing data through surveys such as this. So what does all this mean? Well, we have extensive maps of the marine environment which we've collected from previous studies. We know what is where, but to date we haven't had much supporting evidence as to what the health of that might be, and this study has allowed us to come up with reef health indexes that we will be able to add to the existing maps that we have, which, when overlaid with risk surface work that we've been doing as part of the marine protected areas, we're able to then throw this into our marine park modelling software with goals set for the amounts of areas that we'd like to see protected, and have a look at what a park might look like if we were to try to meet the goals set out in the Caribbean Challenge, or indeed other goals that are established as a result of the stakeholder input. When we do that, the models themselves look somewhat difficult to implement, so the next stage is to introduce the human element, to get people's input into areas that they feel need protection, areas that need improvement, or to indeed see what people would like to see in a marine protected area or in the Cayman's Marine Park environment as we move forward for the next 25 years. So we've heard that there is plenty of evidence that the marine parks are working, but we know we also need to increase or improve on that protection if we are able to survive some of the significant impacts being faced by climate change. So what are the options that are available to us? Well, obviously bigger parks. What does that mean? Simply moving the boundaries of the existing park system that we have, moving them further out to sea, moving them along the shore further so that they encompass bigger areas. These are very simple approaches that might seem rather obvious. Some more sophisticated areas might be alternative park zonation. We've heard that we have a lot of replenishment zones that don't afford much protection to anything else that's in them other than the conchs and lobsters. One of the options might be to consider turning those into marine protected areas or marine parks, which afford better protection to the fish and to some extent the habitats that are in there. Species protection is an area that is one that's open and becomes a bit more complicated, but for instance groupers, when they're in the spag site or in the spawning aggregation, when that site is closed for the 4 months of the year, it effectively becomes a marine park for them. Echinoderms are afforded complete protection in the Cayman Islands, so ostensibly the Cayman Islands marine environment is a marine park for echinoderms. Species such as sharks and rays don't have any protection at all, and these are all areas that we think are ripe for considerable amounts of improvement. If we are to improve the marine park system, there's no doubt that enforcement needs to be addressed. Enforcement officers don't have very many powers, and these need to be improved, but so do the resources that they have and methods of reporting back to the public so that they get a better feeling that marine parks are being enforced. Habitat protection is perhaps one of the key areas that we also need to look at. The marine park systems, although well established, do not afford a lot of protection to habitat, specifically mangroves and seagrasses and patch reef environments within lagoon systems are very, very underrepresented in the marine park system, and it's an area that we feel there's room for significant improvement. Obviously, much of this will require new laws or new regulations, and we feel that the National Conservation Law goes a long way to addressing many of the loopholes, and indeed would be a significant improvement to the marine park system. Although it's not part of the review, it's definitely one of the areas that can greatly help. Alternative park locations is another kind of simple approach. Basically keep the existing areas that we have, keep the existing system that we have, and introduce new ones. New marine parks perhaps in the North Sound, perhaps on the South Coast, which is vastly underrepresented in the marine protected area system. So those are some of the options. What do they mean? Well, ultimately we feel that they would improve the resilience in the marine system by promoting a much more healthier reef system. More fish ultimately feed back to healthier reefs, as we've learnt that relationship is very, very important. Once reef systems become more healthy, we get better coastal protection. We all know the values of reefs that they provide around through calming of the ocean, protecting coastlines from violent wave action. Obviously reefs form many other functions, including becoming a very important financial backbone through the tourism and the fishing industry. And we feel all of these areas will improve dramatically, or at least be safeguarded through more resilient systems if we're able to improve the current protection that we have around the Cayman Islands. And now that brings us to the end of the meat of the presentation, and we will now hear from Gina about some of the options that are available for people that would like to feed into this system and to be part of the review.
So at this point, really all that's left is for me to invite you to provide your input to us on whether you think we have addressed all the threats, whether we've identified them all, whether you have ideas about how these threats can be better managed. But most importantly, we want you to provide us with your vision for the marine environment in the next 25 years. What would you like the marine environment of the Cayman Islands to look like in the next 25 years? Do you want to see a marine environment that looks like this? Loads of fish, healthy corals, quite significant diversity on the reefs, clear water, or like this? Both of these sets of pictures were taken on the reefs around the Cayman Islands over the last few months. We therefore need to make some very key decisions about how we move forward in protecting our marine resources, and we need your input. We're going to take your input, combine it with our long-term data, and with the habitat maps that we have gathered over the last few years, and design various options for improving protection of the marine environment around Cayman. We will map those options and come out to the public again to seek input on the various options. We welcome your comments now in terms of your vision for the marine environment for the next 25 years for the Cayman Islands. Please write into the DOE at doe@gov.ky. You can also telephone 949-8469. And if you go on our website, www.doe.ky, you can get some more information on the Darwin Initiative and on Cayman Islands Marine Parks. Thank you for listening.